probably not too hard for you to discern that if we're going to rotate a region around the y-axis, the formula is really going to be just about the same. Without even going through the Sally method, you could say, well, if I was using washers, it would be pi times the region x equals f of y squared minus x equals g of y squared. If we looked at f of x as the outer function and g of x as the inner function, times the thickness delta y, which is going to wind up being dy in the integral formula. So we're going to use the washer method to determine the volume of the solid generated revolving around the region about the y-axis when the region is bounded by y equals x minus 1, y equals 1, and x equals 1. Well, x equals 1 is this horizontal line. Sorry. X equals 1 is this vertical line. Y equals 1 is this horizontal line. And y equals x minus 1 is this line with slope 1 and y-axis intercept at negative 1. So really, if you can imagine taking this blue triangle and rotating that around the y-axis, that's the region. This light blue stuff that's shaded is actually hollow. So we're trying to find this clear, or maybe if you think of it as, yeah, it's clear. It's like it's made of glass, and we can see the hollow part on the inside where somebody put paint. So hopefully you can visualize what we're trying to find here, and let's go about this thing. By the way, x equals y plus 1 is this as a function of x, and x equals 1 is this one as a function of x. So it should we should be able to do this by looking at our sample disk. Here's our sample disk. I tend to use sorry, it's not a sample disk, it's a sample washer. So it's pi times from 0 to 1. Those are y limits from here to here. Y plus 1 squared is the outer, 1 squared is the inner, and dy is the thickness of the disk. And so we just need to integrate y squared plus 2y plus 1 and then minus 1. So that's y squared plus 2y. Integrating that, we get y cubed over 3 plus y squared from 0 to 1. Put in 1, we get 1/3 plus 1, which is 4/3. Put in a 0, we get nothing. So this should be 4 pi over 3. In other words, a little bit bigger than 4. And you figure, well, that seems like a pretty reasonable answer. Why is that such a reasonable answer? Well, imagine that it was not hollow and it was just a cylinder of radius 2 and height 1. Then that would be 4 pi. And we've got to cut this cylinder out of it. And that one is 1 pi. So that would be 3 pi. And so we're also going to not include this part that's kind of below the slanted part. And so that seems reasonable to say it's less than that 3 pi. And 4 pi over 3 is slightly less than that, so it does seem like a very reasonable answer.